In this video, we will solve two problems utilising the ideas of equilibrium and moments. In this first question, Gemma 45 kilograms and Kate 55 kilograms are sitting on opposite sides of a balanced seesaw with the fulcrum in the middle. Kate sits 1 metre away from the fulcrum. What distance is Gemma away from the fulcrum? First thing we must do is draw a diagram with all the information we've been given. So we have a seesaw with a fulcrum in the middle. We have Gemma, who is 45 kilograms, so we need to change that to a force. So I have M times G, which will give me 45 times by 9.8 to give me 441 newtons. We also have Kate, which is mg also, and I now have 55 times by 9.8. And if we put that in our calculator, I have 539 newtons. We have some extra information here about the position of Kate. She is 1 metre away from the fulcrum, and we're trying to find the distance of Gemma away from the fulcrum. So let's also state whether Kate or Gemma are clockwise or anti-clockwise moments. So if I was to place a pen along the length of the lever and I was to move it in the direction of Kate, I can see it would be moving in a clockwise direction, and Gemma is in an anti-clockwise direction. So let's use sum of moments anti-clockwise is equal to the sum of moments clockwise. So let's do a little highlight. So these are our clockwise moments, and these are our anti-clockwise moments. Now we must also write in our equation. So f of Gemma times by r of Gemma is equal to the f of Kate times by the r of Kate. Popping those numbers in, I have 441 times by Rg is equal to 539 times by 1. So Rg therefore is 539 divided by 441 to give me 1.22 metres from the fulcrum. Okay, let's now have a look at this second example. A painter is sitting on a wooden plank suspended at its ends by 2 ropes, left and right. The uniform 3.5 metre plank weighs 280 newtons. At one point, the tension in the cables is measured as 590 newtons in the left and 320 newtons in the right. Calculate the painter's weight and also calculate how far from the left cable the painter is standing. There is a lot of information here and a diagram is essential. So there's my plank. There are my 2 cables, left and right. We have the plank is 3.5 metres. It weighs 280 newtons, so we can say F of the plank is 280 newtons, and we know that the distance from either side is going to be 1.75 metres. Okay, we know the tension in the left cable, and it's going to be an upwards tension or an upwards force is equal to 590 newtons. And the force in the right cable is 320 newtons. We know that these values, that these forces are upwards, because if I were to snip the cable, the plank would fall down. So the force must be providing an upward force to keep the plank in equilibrium. Okay, the next thing we need to do is we need to put our painter in there, and this is F of the painter. Okay, and we don't know how far she is, so that's R of the painter. Okay, all right, let's firstly have a look at the value of the painter's weight. So remember, we have two conditions for equilibrium. One of them is that the sum of forces up is equal to the sum of forces down. Okay, so the upward forces, we know we have 590 plus 320, and that is equal to F of the painter, which will be a downward force, plus 280. So if we pop that into our calculators, we end up with 590 plus 320, take away 280, which will give me 630 newtons. So 6.30 by 10 to the 2 newtons. Right, the next thing we need to do is we need to work out the position of the painter with the plank being in equilibrium. So where to put the pivot? You put the pivot either at the left side or the right side because they're the most convenient places to put it. Seeing as we're being asked to find out how far she is from the left cable, that would be the most logical place to put the pivot. So we should be putting the pivot here. Okay, so big sum of moments clockwise, anti-clockwise is equal to the sum of moments clockwise. So which would give us our anti-clockwise? So anti-clockwise would be this one here. And then clockwise would be this one here, our F of the painter. And we don't need to worry about the force on the left-hand side because it is at a distance of 0 from the pivot. Okay, so our anti-clockwise moment would be F times by R times by the distance of the right cable is equal to F of the painter times by R of the painter plus F weight times by R weight of the plank. Sorry, I'm going to make that plank, seeing as that's what we call it. F of the plank times by R of the plank. Sorry, I've run out of room there. Okay, so let's pop those numbers in. So I have FR is 320. It is 3.5 meters away from the pivot. I have F of the painter, which we've just worked out to be 630. We're trying to find the position of the painter. F of the plank is 280, and it is at the midpoint. The weight force is acting through the midpoint of the wooden plank. Okay, so you just assume that unless they tell you something different. So it's 1.75, which is half of 3.5. So let's pop these numbers into our calculator. So RP would be equal to 320 times by 3.5, take away 280 times by 1.75. Yep, that's right, divided by 630. We actually end up with that being 630 divided by 630. So the painter would be 1 meter away from L, okay, or the left cable. Okay, there you have it. We've solved two problems using equilibrium, the ideas of equilibrium. So the sum of forces up equals the sum of forces down, plus the sum of moments anti-clockwise is equal to the sum of moments clockwise. There's a lot of setting out to do, and that's a really, really important part of doing these problems, because the more complex problems are very, very difficult to do without a diagram and without setting out correctly. Thanks so much for listening to this video. That's the end of it. If you could please subscribe, that would be great. Thank you.